Hey everyone, it's Matt here with Nightrun Studio, and welcome to the new series where we're making a Metroidvania in Unity. In the first video, we got our project set up in Unity 6, imported our first sprite, and set it up with gravity as well as collisions. In this video, we're going to add our first script using Unity's new input system to get him moving and flipping horizontally. Let's get started. Now, if you missed the first video or are just joining us now, the one thing you do need to know is that we've got a empty player game object as the parent here. We've added a rigid body 2D and collider to give him physics and collisions. We've then created a sprite as a child of that object. All right, I think it's time we actually get this player moving by writing a script here. So we're gonna head down to our assets folder, right click and create another folder. We'll call this one scripts and then open that up. Now inside here, we'll create a new mono behavior script, which we will call player. Then we're just gonna click on the player himself in the hierarchy, go to get component and add that player object onto him. Now for those of you who are new to Unity, up at the top here we've got a using line. These are called namespaces and they're just libraries we'll add over time that give us shortcuts for our code. Next we have the class name, which is player, and it's a mono behavior script. Beneath that we have methods. The start and update method come in every mono behavior script, and they just run, as they suggest, when the game is started. So anything between these brackets will run at that time, and then update runs every single frame, so roughly 60 times per second, though that will vary depending on your frame rate. We won't actually be using either of these for now, so we can just delete them. What we do want to do though is access our rigid body 2D. It controls the physics for our player, and we're going to need to give it some controls. Now, for every object that you add into Unity, we need to also give it a name, as this script could possibly be controlling many rigid bodies. We'll just call this one RB, and then we're going to make it public. I'll show you what that does. Now when we're in Unity, we can click on the player and you'll see that there's a new box here for the rigid body. We can drag our actual rigid body in there, and now every time our script talks to RB, it knows we mean this rigid body on the player. Next up, we're going to add our first method. This one is going to be a void fixed update method. Now inside of here, we're just going to talk to our rigid body, and we're going to tell it what we want its linear velocity to be. Velocity is just speed times direction, and we're going in a line here. Now, the velocity at any given time is going to be equal to, and here we're just going to make a new vector 2. A vector 2 being a XY value, so horizontal and vertical. Let's say I gave it a 1 on the X, so that would be right, and a 0 on the Y, meaning not move at all. When we get in the game, this is what would happen. You'll notice he is moving slightly downward, and that's just because in between each frame, gravity is acting on him, and then fixed update in the next frame tries to set him back to 0. So obviously this isn't exactly what we want. Let's improve this by adding some speed. So add a public float called speed, and now down in our fixed update, we'll just multiply our X value times speed. We're also going to get rid of this 0 for our Y value and instead do the rigid body's linear velocity.y, which essentially just means, hey rigid body, do whatever you want on the Y axis. You can have normal gravity. I'm not going to give you any orders. Now when we play the game, you can put different values in here, like -1 to go left, yeah, that just happened, or +1 to go right. Now if you're wondering what on earth just happened there, if we open up our rigid body, he just fell over. So we're gonna go into constraints and we're gonna freeze his Z rotation so that he doesn't do that anymore. Now next up, we actually wanna take in some player inputs to decide where he's going to move. We're gonna be using the new input system for this. So if you head to your assets folder, you should be able to find an input system actions file here, which was auto-generated when we created the game. You can double click this to open it. And here we have a list of different actions the player will take. We're just going to be using the move action for now. If you want to, you can double click it to rename, and down below we have all of our keybinds. There's a left stick if you want to use a gamepad, and also it's auto configured for WASD controls, though you can change these if you want. Over on the right in the action properties, you'll see that it takes in a value, which is a vector 2. That just means that depending on what you press for WASD, it will take in an X and a Y value. Now, if for some reason Unity didn't generate that for you when you started, you can go to Create and then head on down to Input System and we'll get a new actions list here. You can name this whatever you want and then double click it to set it up. Once it is set up, you'll want to go to Edit, Project Settings, and then over here in the Input System package, make sure that you make this new file you created your project-wide action file. Finally, just make sure to click on player, and if you scroll way down here, you'll find that we have this active input handling. You're going to want to pick the new system or both if you think you might want to use them both. One last thing before we get to our script, while clicked on your player, you're just going to want to add the player input component. You'll see that it auto found our action mapping. And if you want, you can change the default scheme to only take in, say, keyboard and mouse or gamepad, but I'm just going to keep it at any so that they can all work. I'm also just going to move the input system up to the top here with my other Unity made components. That way I can keep my scripts down below. All right then. Back in our script, we're just going to make a reference to that input system. It will be a public player input, and we'll just call it player input. Now, if you followed my other videos, I've always used the old input system up until now. The new one is a lot more powerful. That said, it takes a little more work to set up. So the first thing we're going to have to do is actually make it so that we can track the different inputs. Now, to take in those inputs, we're going to create a public void method called onMove. The reason it's called onMove is because if we go back to our project settings, you can see that the input we're taking in is move. And so we just add the on. Anytime movement is pressed, then it'll run it. So in our script, our onMove method is going to take in a value. It's an input value, and we'll just name it value, though you could call it whatever you want. Now, in order to keep track of what button we're pressing, we need a place to store the value. So we'll come up top here and make a public vector2 called move input. This will just constantly store an X and Y value for what we're pressing. Now then, in onMove, we can tell our move input what it should equal. And it's just going to be equal to the value, which gets passed in by Unity anytime we push a horizontal or vertical direction. And from the value, we just want to get a vector2. We're just about ready to test that, but if we went into Unity now, we'd get an error, as it's not going to know what player input is. We need to come up top and add another namespace, in this case the using Unity engine.input system. This allows it to know what we mean when we talk about the player input. Back in Unity, we'll just click our player and make sure to fill that player input box with our player's input. We can then test it out. If you look in the inspector now, you can see that when I push right or left, the move input value does change for our X. So I'm taking in an input, and if I give myself speed, my character starts moving, but the two aren't yet talking to each other. Now, to make that happen, we'll head on up to our fixed update, and we're going to create a local float here. We'll call this one target speed, and it's just going to be equal to our move input.x, and we're going to multiply that by speed. Now then, when we set our velocity for the x value, we can just put that target speed variable. No setup necessary, except to make sure that you give your player a speed. And now when I press left and right, we'll move. That said, I don't want to leave you here. This is just weird at this point. We want to make sure that that player is actually flipping left and right depending on which button we press. Now, there's a number of different ways that we can flip a character in Unity, but we're going to be using the local scale method. What this does is allow us to just go to our X value here in scale, and if it's positive, we'll face right, and if we make it a -1, he'll move left. This actually moves not just the player, but also any children of him, which is why our sprite flips every time we change the parent's value. So the first thing we need to do is just find a way to track which direction the players should be facing. For this, we're going to make a public integer, so a whole number, called a facing direction. And since our player faces right by default, we'll make this start off as +1. Next, we're going to create a flip method, which will contain the logic for detecting when he needs to flip, and will actually do the flipping itself. So what we're going to do here is just make a conditional statement. So if our moveinput.x happens to be greater than, and here we'll just pick a very small positive number like 0.1f. Now that means we're pushing to the right, and if we are pushing to the right, we want to make sure that facing direction is 1. Now we also need to account for if I'm pressing left. So here we'll make an else if statement, which is if moveinput.x is less than -0.1f. Now what if we're not pressing anything and our move input is 0? Neither of these will run then, and our flip method just won't do anything, which is what we want. At this point, we've got some great logic here, but it will never actually do anything as our flip method is never being told when to run. Here we're going to add back the update method, and that way we can call flip every frame so that our player is constantly checking if he needs to change direction. Now when we get in Unity, you'll notice when we press left and right that our facing direction is in fact changing. That said, it's not actually applying itself to our scale yet. To do this, we'll head back into our code, and at the bottom of our flip method, we're just going to talk to our transform and tell it that its local scale needs to be equal to. Now here we can't just set the x, we have to set all of the local scale. So we'll make a new vector3. The x value will be equal to our facing direction, and then for y and z, we're just going to put a 1. Now when we get into our game, as long as we have a speed value, we can finally move right and left, and the player actually flips. I hope you found that one helpful. In the next video, we're going to look at how to get our player jumping, complete with variable jump heights depending upon how long you hold the button down. Hope to see you in that video. Until then, this is Matt with Nightrun Studio. Cheers.